Alright guys, so the next thing we're going to talk about is getting rid of fractions from equations. So for example, I don't know, 2x plus 1/3 equals x plus 5. Okay, this is a simple one because there's only one fraction. And so what we do, and I'm going to rewrite this out, what we do is we want to get rid of denominators, because if we don't have denominators then we don't have a fraction. So you find the common denominator. In this case there's only one denominator, so it's 3. And essentially what you're doing is you're multiplying everything, every term on both sides by the reciprocal, 3/1. Okay, so let me use a different color here, but you know, this is 2x/1, 2x, 1/3, 1/3, x, and you could write x/1 if you wanted to. You know, I should have moved it up a little bit, but anyway, here's the x term, and then here's the 5. And so I'm flipping this to get 3/1, and I'm multiplying every single term both sides. And this is what happens. It's essentially to get rid of the denominators, and so again, therefore you're not going to have any fractions. Here I have 1 on the bottom. There's nothing to cross cancel with, so I'm just going to multiply straight across. And by the way, you know, you don't have to cancel right away. You can reduce the fraction and the denominator will go away naturally. So anyway, there's nothing to cross cancel here, so I have 3 times 2x is 6x. Bring down the plus. Now here, the 3 on the bottom, cancel. It divides into itself once, it divides into this once, so what you end up with is 1 times 1, which is 1. Or you could write 3/3, 3 times 1 is 3, over 3 times 1 is 3, and then cancel it, you know, reduce it, and you'll get a 1. Okay, over here again, the denominators, there's nothing to cross cancel, so I just have 3 times x is 3x. Bring down the plus. And here, this is 5, or 5/1. There's nothing to cancel, so 5 times 3 is 15. Now we have a simple equation that we can solve for x. We could subtract 3x from both sides. So combining like terms, we're going to have 3x plus 1 is equal to, that cancels, 15. And if I subtract 1 from both sides, I'm going to have 3x is equal to 14, so x is 14/3. And if I want to find y, well, of course, you know what to do there. I can plug it into here, or into some other equation if I'm given another equation, and solve for y. Here's another one. Let's see. X minus 1/2 is equal to 4/3 x plus 2. Now I have more than one denominator. I have 2 and they're both different. So if they're the same, then, so if this was a 2 and that was a 2, then really easily you just use 2 and multiply through. These are different, and when they're different, you just multiply all the different denominators together. So 2 times 3 is 6. So I'm going to write 6 times x, okay, bring the minus down, minus 6 times 1/2 equals 6 times 4/3 x, oops, plus 6 times 2/1. And again, you can put the x/1 if you want to, and you can even put the 6/1 if you want to, if that helps you. Okay, so nothing to cancel here. If 6 times x is 6x, bring down the minus. Now look, I'm not going to reduce yet. I'm just going to multiply. So 6 times 1 is 6, over 1 times 2 is 2, is equal to 6 times 4 times x is 24x, over 1 times 3 times 1 is 3, plus 6 times 2 is 12, over 1. And now if I reduce this thing, I can't do anything with the 6x. I know that 6 divided by 2 is 3. I know that 24 divided by 3 is 8 times x, so don't forget your x. And 12 divided by 1 is just 12. And now I've got a simple equation again. I can combine like terms, so perhaps subtract 6x from both sides. We have negative 3 is equal to 2x plus 12. Subtract 12 from both sides. So it looks like 15, negative 15 is equal to 2x. And so we would get x is equal to negative 15 halves. How about this one? 1 over x. Oops. Alright, scratch that. 1 over x plus 1/3 x minus 1 equals 5. What's the common denominator? The things that are different are x and 3. So I'm going to multiply every term, both sides, by 3x. So we have a 3x here, and we're going to multiply it by 1 over 3 times x. I have a minus that I'm bringing down, so 3x times 1 is equal to, oops, 3x times 5. And look here. Here, the x's are going to cancel, so I'm left with 3 times 1 is 3. Here, the 3's are going to cancel. Now, the x's are not going to cancel. Remember, this is over 1, and this is over 1, so this is on top. So x times x is x squared. Okay, so that one's done. I'm going to bring down the minus. 3x times 1 is 3x is equal to 3x times 5 is 15x. Capiche? And that's really all you have to do. And in fact, if you had something like, move this paper. Suppose you had, 1/5 x plus 1/2 minus 2/3 is equal to 4x minus 1/4. Oops, losing focus here. Not sure why. Let me try and fix it. There we go. Well, now I've got a bunch of denominators, right? This is a 1. I have 5 and 2 and 3 and 4. They're all different. So when worst comes to worst, I'm going to multiply. 5 times 2 is 10. Times 4 is 40. Times 3 is 120. So I would be multiplying every term, both sides of this equation. Now I could combine those if I wanted to, but it's easier not to. And then I would get out my calculator and, say, well, 5 goes into itself once, and it goes into 20, how many times? So 54. So it goes in here 54, so I'm left with 54 times 1 times x is 54x. Bring down the plus. 2 goes into itself once, it goes into 120, 60, so I'm left with 60 times 1 is 60. Bring down the minus. 3 goes into itself once, it goes into 120, 40 times, so I'm left with 40 times negative 2, well, that's negative 80. Bring down the equals. Here there's nothing to cancel, so it's 120 times 4, which is 480x. And here 4 goes into itself once, and it goes into there 30 times, so I left with negative 1 times 30 is negative 30. So even though they're big numbers, there aren't any more fractions, so it makes it a lot easier to work with. Hope this helps. See you Tuesday. Bye. There we go. Okay guys, so sorry that took a minute to straighten out, but we're going to go over some operations with fractions because you asked me for it. Okay, so the first thing is we have like fractions, okay? And like fractions have the same denominator, okay? They have the same denominator. And what that means is they're easy. Okay? Why are they easy? Because if the fractions have the same denominators, then you can just add or subtract the tops, okay, the numerators. So for example, a third plus 2/3, the denominators are the same, so it's going to result in a new fraction with 3 in the bottom or in the denominator. And now I could add the top. 1 plus 2 is 3, and then we can reduce if we need to, okay? I don't know, 2/5 plus 3/5. Well, the bottoms are the same, so we're going to have a new fraction with a denominator of 5, and then we can add 2 plus 3 is 5, and reduce again if we need to, okay? Maybe you have something like, I don't know, 7/3 minus 4/3. Well, again, the denominators are the same, so we're going to have a denominator of 3. And 7 minus 4 is 3, so we get 1. Now, they don't all turn out to be 1. I'm just like making stuff up, and it's working out that way. Okay, so I don't know. Let's see. 3/13 minus 5/13. Okay, so the bottom's 13, and the top is 3 minus 5. Well, remember, that's 3 plus a negative 5. Okay, if you want to do it that way. The signs are different, so you subtract 5 minus 3 is 2, and you assign the sign of the bigger number. The bigger number is 5, and it's negative, so we make that negative. The problem you guys have is when the denominators are not like, because then you can't just add or subtract the numerators. So, for instance, 1/3 plus 1/5. You can't do anything with it until you come up with a common denominator. So to do that, we're going to multiply each one of these by an equivalent fraction. We need the bottoms to be the same, right? So I'm going to multiply 1/3 by 5/5, the denominator of this one. Bring over my plus. And now I'm going to take this next one, 1/5, and multiply it by 3/3. And when we multiply straight across the top, so 1 times 5 is 5, or 3 times 5 is 15. Over here, 1 times 3 is 3, over 15. Now the denominators are the same, so we're going to have a new fraction with a denominator of 15, and now we can add the tops. 5 plus 3 is 8. Okay? I don't know, 4 minus 2/3. So you can write 4 as 4/1. And then again, we're going to multiply this one by 1/1. If you want to think of it that way, you don't have to do anything with this one. And you're going to multiply this one by 3/3. And now if we clean that up, we're going to have 3 times 4 is 12/3. Bring down the minus. 2 times 1 is 2/3. Denominators are the same, so now we could add or subtract the numerators. 12 minus 2 is 10. Okay, that's pretty much it. Here's some for you to try. I don't know. Okay, so give those a whirl, and if you have questions, you can ask me in class. All right, have a good night.